Hello everyone, my name is Kathryn Wheeler and I'm a PhD candidate at Boston University. And today I'm going to be giving a tutorial on how to access and use two different meteorological covariate data products. These two products are ensemble based, which is how they are able to use estimate uncertainty, which is very important to be able to incorporate into your forecast and include in your forecasted state variables. The first product is the NOAA GEFS forecasted metadata product, which is directly provided from EFI. And the second one is the ERA 5-year analysis product, which goes back a couple of decades, and it includes a variety of met variables and other quantities that you might need to use in your forecasts. And today I'm just going to give an overview of both of the different products, and then also go into an R Markdown and show you some code of how to download and use the products. So the NOAA GEFS, or the Global Ensemble Forecasting System, has two different temporal resolutions, either the 1 hour or the 6 hour, and they are ensemble based, as I mentioned, and there are 31 ensembles, and they're stored in separate netcdf files. And EFI directly downloads these and makes them available for you, and they're available for different times daily, and the EFI directories are organized by the different cycles. So you have the midnight cycle, 6 a.m., noon, and 6 p.m. And it's important to note that there are two different forecast horizons associated with the product. You have the midnight forecast has 30 ensemble members 1 through 30, that extend 35 days into the future. And all the other cycles, and also the midnight 00 ensemble, only extend 16 days in the future. Many of the forecast challenges, such as the phenology forecast challenge, require you to make forecasts 35 days in the future. So we recommend you utilize the 30 ensemble members for the midnight forecast. But if you think you can utilize the other ones too, by all means do so. It is important to note that the 35-day forecast files are a lot bigger, so they take a lot longer to download, so they might not be quite available quite enough or quite early enough or as fast as the other ones are. So just, if you're looking at the file system and you can't see them, just wait, because they're probably still downloading. Some of the met variables that are included in the products that are stored in the EFI servers are, you have the air temperature and pressure, wind speed, precipitation, and then the downwelling, long wave and short wave variation, and also relative humidity. And there are different ways you can access them via the EFI server. One is just to click on the file in the browser, which I can show you now how to do. So they are stored in these folders. You can just go and click, say you want the 1 hour temporal resolution, you click, say, Bartlett. They have them back through September, so you just want the October, the midnight cycle, and you have your 31 ensemble members listed that you can just click on and download the object, as easy as that. You are also able to just directly download the individual files from the command line using the file address, or you can use AWS commands to directly download the files. But for your convenience, EFI also provides an R function code in the NEON forecast package in the script called NOAA.R, which downloads all the ensemble members for a specific NEON site and a forecast cycle. Then you have the ERA 5-year analysis product, and this is the 5th generation ECMWF reanalysis for global climate and weather. And data is available back from the 1950s via a back extension, but the main product is available from 1979 onwards. And they provide hourly estimates for a large number of atmospheric, ocean wave, and land surface quantities. And as I mentioned, it's ensemble based, so they provide 10 ensembles, but those, for the uncertainty products, such as the ensembles, they're only provided at 3-hour intervals. And they also provide a mean and spread if you don't want to directly deal with the ensembles. And they're available at a latency of about 5 days, so that if you're needing to submit a forecast today for what it is tomorrow, you might have a latency and a gap between your ERA 5 calibration period and then your historical period and your forecasted period. And something that our lab does is we actually use the NOAA GEFS forecast to gap fill those 5 days by saying the forecast for today from yesterday, we just treat as equivalent as the Error 5 product. Obviously, this inserts a level of uncertainty into the forecast, but you do what you got to do. Or you're obviously free to use other MET products if you want. And then this Error 5 product has a quarter degree by quarter degree spatial resolution, other than the uncertainty products such as the Ensembles, and those are about half a degree spatial resolution. And examples, there's a lot of different variables that are associated with them. I just listed some examples here that I thought would be interesting to talk about, but definitely check out the catalog because there's a lot that might be related to your specific forecast challenge. So you have the 2-meter air temperature or air pressure, the 2-meter dew point, wind, surface downwell and shortwave and long wave flux. You have evaporation, you have leaf area index or LAI. And I found it interesting, they do have some other like lake related things for the aquatic folks. So you have the lake bottom temperature, lake depth, lake ice depth, and also total precipitation, which is not just like related, but it's related to a lot of things. Accessing Error 5 data, you can either download it directly from the website, or you can access it via API, which I'm going to show a little bit of that, but we're not going to go into setting up your API because I think their instructions lay it out very well. So because you have to request a key and set it up on your computer, but they lay it out very well, but it also differs a lot between operation systems, and I don't want to assume everyone is using a Mac. But you can download it directly from the website. So if you click, say you're Ensemble members and you want to download your temperature, but they have, as I mentioned, a lot of different things ranging from clouds, length, soil, vegetation, etc. Say I just want to do it for January of this year, and this is the first 2 days, all the time periods, sub-region around Massachusetts, and they have it available in the GRIP format or the NetCDF format, which I usually use the NetCDF format, so we'll request that. And then, I was missing something. Oh, I unclicked that. And then you can submit the form, and then it will wait, and then it will be available to download, easy as that. You can just download it, and it'll be available for you to utilize. But you need to create an account on that to be able to access it. And now I'm going to show a tutorial on how to use some of the data. And this, our markdown file is available on the meetings GitHub repository, so feel free to look at it. I included the downloaded data for the Error 5 just because it doesn't normally download with a script because you need the API to go to the website to do it. So make sure you have your libraries loaded. I'm not specifically using the NEON Forecast package because I'm just going to source the function directly from the website. But if you want to download the package and install it, feel free to do it. There's a lot of other useful functions in it. And I'm going to show example data site for one NEON site, the Harvard site. So you have the Harvard ID, the lat long, and I also have information in this file that I included on the PowerPoint. So we're just going to source the function from the website or from GitHub, and then we're just going to download it for February 1st of this year, the 1 hour time interval, the midnight cycle, and then we download it. And then it will pop up in whatever directory you tell it to download it in. The function creates its own node subdirectory, and then it nests a bunch of things until eventually you can see that you have the 31 downloaded ensembles, each in their own NetCDF file. So now I was going to read in the data. I'm going to create a variable to store in all the temperature data from all the different files. And as you can see, because it's an NetCDF file, we use NC Open to open it. Time can be taken out or accessed via the dimension of the variable time. And then I'm just going to get get to the variable temperature and then add it to all temperature variable. So we can just plot one Ensemble member for 35 days into the future for Harvard. And again, this is a 1 hour temper resolution. And then we can add on the 29 other Ensemble ones that go 35 days in the future. And it is noteworthy that they're a lot closer in spread for the first couple days, and then they vary a lot. This is expected. We're much better at forecasting like today's temperature and tomorrow's temperature than we are 30 days in the future. And again, this is another reason why we feel it is sometimes okay to be able to use the first couple days as historical temperature data for your previous couple days if you don't have ERA5 data yet. And because you have Ensemble members that provide estimates of uncertainty, we're able to calculate the confidence interval and plot that. So that's the median spread. And then we have the 95% confidence interval and the median line spread on that again. So again, you can still see the confidence interval is very narrow and then opens up a lot and then doesn't keep increasing, but it remains like a pretty constant width in the future. Okay, so now the ERA5 reanalysis product. We're just gonna, I provided data for the month of January of this year. And that's a file name. Again, it's just in the repo, in the data folder, it's just right there. So you don't have to download it, because once you are able, if you want to use the API, there are code here that they also provide on the website, but these are some more examples of a variety of different variables you can use. I only requested for the first variable, which is that I list here, which is air temperature. And then that's how you request it. But then you can just net CDF file, so you open it the same way as you did before. Currently, this one only has one variable in it, so you don't need to specify the variable with that command. And it is given, just like in NOAA GEFS, they're given in Kelvin, so you have to convert it to Celsius. Or you don't have to, but just, I don't know about you, but I don't think about things in terms of Kelvin. I think about things in Celsius and Fahrenheit. So we'll convert that to Kelvin, and then time is accessed the same way, and then convert that to time that we would understand. Dates. So you can plot the first Ensemble member, and then you have the 9 other Ensemble members. And because it's the reanalysis product of the past, which uses observations, you see the spread is a lot smaller, unlike the NOAA GEFS. And like the NOAA GEFS, you can create a confidence interval. So let's calculate that, and then plot the median, and then the 95% confidence interval, and then the median again. So as you can see, yeah, it is a much smaller spread. So I hope you guys learned something about how to access and use the NOAA GEFS and also the ERA5 data. There are a lot of different covariate and also meteorological data products out there. But again, I think it's something that's really important for a lot of data products to use is trying to find data products that have measures of uncertainty, because uncertainty is very important. But let me know if you have any questions. My email is in our markdown file, and thank you for listening.